Okay, so Assalamualaikum warahmatullahi wabarakatuh. This is chapter 10, Special Probability Distribution, and this is lecture 3 out of 4, where we are going to learn about the normal distribution. Okay, so the learning outcome is that you should be able to identify the normal distribution, use the formula to standardize the normal random variable, find the mean and variance of the normal distribution problem, use the distribution table to solve a related problem. Okay, so the normal distribution is one of the most important distribution in statistics. If a continuous random variable x has a normal distribution with mean and standard deviation, then we write them down as x is a normal distribution. So this is basically the mean. Okay, so this is basically the mean, and this is actually the variance, or you can say that it's supposed to be standard deviation squared. Okay, so the normal probability distribution or normal curve is given by a bell-shaped curve. Such a curve is shown in the next slide. It has a mean of mu and a standard deviation of sigma. A continuous random variable x that has a normal distribution is called a normal random variable. Okay, so this is the shape, the bell-shaped curve. So over here we have the axis of symmetry, where the axis of symmetry is the mean, and this is the standard deviation to see how dispersed they are. Okay, so a normal probability distribution, when plotted, give a bell-shaped curve such that the total area under the curve is equal to 1, and the curve is symmetric about the mean, and the two tails of the curve extend indefinitely. Okay, so now let us talk more about this. A normal distribution possesses the following three properties. The first one, the total area under a normal curve is 1 or 100% as shown below. So that means if this is your bell-shaped curve, if you shade everything below your curve, the total area should be equal to 100%, or the area should be equal to 1. Okay, the second one, a normal curve is symmetric about the mean. So what does that mean is that if this is your bell-shaped curve, the right hand side is actually equal to half, the left hand side is also equal to half, and when we add together both of them, we are going to get 1. So that is what they mean over here. Okay, next, standardizing a normal distribution. So this is actually the procedure to convert the given normal distribution to the standard normal. The unit of a normal distribution are denoted by x. So this is a normal distribution. The standard normal distribution are denoted by z. For a normal random variable x, a particular value of x can be converted to a z value by using the formula. So in order to convert from x to z, we are going to use this formula where z is equal to x minus mu over sigma, where mu and sigma are the mean and standard deviation of the normal distribution of x. Okay, so the standardizing of a normal distribution. Okay, so we started with a normal distribution x with mean mu and then sigma square, which is the variance, and then in order to standardize them, we have to use z equal to x minus mu over sigma. So what happened here is that we are going to change from x to z. So now this is a standard normal. The left hand side, this is a normal distribution. The right hand side, z, this is a standard normal distribution with mean 0 and variance 1. Okay, so referring to here, this is the standard normal distribution, and as you can see, that letter over there, that is actually equal to z. So this one is actually z. Okay, so that means if you have any question involving a normal distribution, what you need to do is that you need to change them into a standard normal distribution before you can use the table, because we only have one table and that is for a standard normal distribution. Okay, so to find the z value for any x value, we need to calculate the difference. So this is the meaning of z equal to x minus mu over sigma. So this is what they mean. Okay, so basically if x is equal to the mu, as you can see over here, if x is equal to mu, then that means x minus mu is simply equal to 0. Then that means the value of the z is equal to 0 over sigma, which means that z is definitely equal to 0. Okay, so we always round z up to 2 decimal places, because when you want to use the table, we only have 2 decimal places. So be extra careful when you are calculating x minus mu over sigma. Always make sure you round them up to 2 decimal places. Okay, so now let us go to some example. Okay, so we have a standard normal distribution over here. The first one, we have to calculate the probability for z greater than 1.2. And then the second one, we have to calculate the probability for z in between -2 as well as +2. Okay, so now probability for z greater than 1.2, let us draw the bell-shaped curve. Okay, so right in the middle, that is your mean. So mean is 0. So 1.2 is definitely on the right hand side. On the right hand side of 0. Greater than 1.2, so that means I'm looking at the right hand side of 1.2. So let us shade the region. So this is the region that we want to find. So now we can directly read from the table, because the way we read our table is always to the right hand side. Okay, so let us read the table then. Okay, so greater than 1.2, so always make sure this is your z. Find out where is 1.2, so this is 1.2. Look at the second decimal, so this is 1.20. So the second one is 0, so we are looking at 0.00. Okay, so what is the value? So the value for this one is 0.1151. Okay, very good. Let us go to the next one. Okay, so probability for z in between -2 and 2. Again, draw your bell-shaped curve. Okay, so -2 on the left hand side, +2 on the right hand side. Okay, so actually I can separate them into 2 regions. So A is on the right hand side of my mean, so this is A. And then B is on the left hand side of the 0. Okay, so let us calculate the A part first. Okay, so this is 0 up until 2. So how are we going to calculate this region? Okay, so the way we read our table is always to the right hand side. So let me start with 0 to the right hand side, minus with 2 to the right hand side. So this one is probability for z greater than 0 minus probability of z greater than 2. Okay, so probability of z greater than 0, the value is simply 0.5, because this is right when we separate them into half. Okay, so 0.5 minus probability of z greater than 2. So now you can read from your table what is that value. Okay, so now for the B part, I actually have something with a negative region, so I'm going to flip them over to the positive side. Okay, so if I flip them, so instead of having -2, I flip them to have a +2. It will simply be the same region when I flip them. Okay, so this one is simply greater than 0, greater than 2. So this is probability of z greater than 0 minus probability of z greater than 2. And then of course you can use the table for them. Okay, so if we combine both of them, what we are going to get, so 0.5 plus with 0.5, that is actually equal to 1. And then we have probability of z greater than 2, probability of z greater than 2. So that means I have 2 times probability of z greater than 2. Okay, so please find out what is this value from your table. So that is 0.0228. So the answer for this is 0.9544. Okay, next. Okay, so if Z is a standard normal distribution with mean 0, variance 1, find A. If probability for Z less than A is equal to 0.9222, and then B, probability of Z greater than A is 0.2358. Okay, so now what you can do? Okay, probability of Z less than A is 0.9222. So basically draw the bell-shaped curve. Okay, so the mean over here is 0. So draw your mean. Mean here is 0. So now we need to decide where is A. Is it on the left hand side? Okay, so let us see. Is it supposed to be here or is it supposed to be here? Should it be on the left hand side or should it be on the right hand side of our mean? Okay, so if you read over here, Z less than A should be 0.9222. So this value is actually greater than 0.5. Okay, if let's say my A is on the left hand side, so this value over here is definitely smaller than 0.5. So why did I say that? It's because from the left hand side until our mean, this value over here is 0.5. So if the A is on the left hand side, this value is definitely lesser compared to 0.5. Therefore, my A need to be on the right hand side. So it shouldn't be on the left, it should be on the right hand side. Okay, so that is my value of A. Okay, so now how are we going to get the value of A? Right, so basically we cannot use our table because this value is greater than 0.5. So I need to find this small region because that is smaller than 0.5. Okay, so how do we calculate this small region? Okay, so basically probability for Z less than A, that is actually equal to 1 minus probability of Z greater than A. Obviously, of course, probability of Z less than A, that is supposed to be equal to the total probability, which is 1, minus probability of Z greater than A. Therefore, if I want to find probability of Z greater than A, probability of Z greater than A need to be 1 minus 0.9222. Therefore, probability of Z greater than A will be 0.0778. Okay, so now, based on your table, do check what is the value of A such that the value inside your table will be 0.0778. Okay, so do check. Therefore, the A is equal to 1.42. Okay, the second one. Probability of Z greater than A is 0.2358. Again, draw the bell-shaped curve. So right in the middle, this is 0. So now we need to think a little bit, where is A? Is it on the left-hand side or is it on the right-hand side? Okay, so referring to this symbol over here, Z greater than A, so that means I'm going to the right-hand side. So if this is my A, that means everything on the right-hand side. However, if the A is on the left hand side, this value is definitely need to be more than 0.5 because the total from 0 up until the right hand side, that is supposed to be 0.5. So if I started on the left hand side, this value is definitely more than 0.5. So that means my A shouldn't be on the left hand side and it should be on the right hand side. Okay, so that means the A need to be here, and then this is the region where Z is greater than A. Okay, so now the region for z greater than a is 0.2358. So now you can actually straight away referring to your table which one that will give you 0.2358. So basically from the table we can see that if z is greater than 0.72, we are going to get the total probability 0.2358. Therefore, you can see that the value of A is definitely 0.72. Okay, next. Okay, so if X is a normal distribution, so this is X, that means X is a normal distribution, it's not a standard normal. So X is a normal distribution with mean 25 and sigma square 16. Find probability for X in between 25 and 32, and the second one probability for X in between 18 and 34. Okay, as you can see over here, this is X. In order to use the table, I have to change it to Z. Therefore, I need to use Z equal to X minus mu over sigma. So I have to know what is the value of the mu and what is the value of the sigma. And then once I standardize everything, then I can use my table. Okay, so let us proceed. Okay, so now A, probability for X in between 25 and 32. So let us standardize them using the formula. Okay, so Z is equal to X minus mu over sigma. So basically the mu is 25 and then the sigma is actually equal to 4. So X minus mu over sigma, X minus mu over sigma as well. So 32, 25, 25, 32. Okay, so when you simplify them, you are going to get probability for Z in between 0 and 1.75. So now draw your bell-shaped curve. And then make sure you shade the region where is 0 and 0.75. So this is our region that we want to find. So the way we read our table is always to the right hand side. So I will need to read from 0 to the right hand side and then minus with 1.75 to the right hand side. Okay, so probability for Z greater than 0 minus probability of Z greater than 1.75. So this is 0.5 minus 0.0401. So this is 0.4599. Okay, next. Okay, so probability for X in between 18 and 34. Again, Z is equal to X minus mu over sigma. So make sure you standardize them, change it from X to Z. Make sure you write them down in 2 decimal places. Okay, so right now we have negative 1.75 and then we have 2.25. Draw the bell-shaped curve. Okay, so negative 1.75 on the left hand side, 2.25 on the right hand side. Okay, so how are we going to calculate this? Okay, so basically I will take the total probability, which is equal to 1, and then I'm going to deduct the left hand side as well as the right hand side. Okay, so 1 minus probability for Z less than negative 1.75 minus probability of Z greater than 2.25. However, this is Z less than a negative number, so by using the symmetrical, this is actually similar to probability for Z greater than 1.75. Okay, so let me write them down. So this is 1 minus probability for Z greater than 1.75 minus probability for Z greater than 2.25. So again, use your table for them. And then the value will be 0.9477. Okay, next. Oh, where's the question? Okay, never mind. Right, so if X is a normal distribution with mean and 100, Find the value of mean if probability for x greater than 77.5 is equal to 0.1736. Okay, so now the mean, we didn't know what is the value, so we want to find what is the value for the mean. But I know the variance is equal to 100, so that means my sigma is equal to 10. Okay, so what do we have is probability for x greater than 77.5 is 0.1736. Okay, so this is x. That means this is not standardized yet. So let us standardize using the formula. X z is equal to x minus mu over sigma. Okay, so z greater than 77.5 minus mu over 10. So this is 0.1736. Okay. Right, so now let us draw the bell-shaped curve. Okay, so that is our mean. So I need to know where is this region. Is it on the left hand side of my mean or is it on the right hand side of the mean? Okay, so whatever value of this is supposed to be z greater than something. So if I write them down on the left hand side and I keep on going to the right hand side, this value is definitely greater than 0.5. But this probability is less than 0.5, so I know for sure the value need to be on the right hand side, so that this value can be 0.1736. If I write them down on the left hand side, that value should be greater than 0.5. Okay, so this is 77.5 minus mu over 10. Okay, so we need to refer to our table which value of z that can give us 0.1736. Okay, so from the table, if z is greater than 0.94, we are going to get 0.1736. So this is z greater than 77.5 minus mu over 10, and this is z greater than 0.94, so I can directly compare them both. Okay, so 77.5 minus mu over 10 is 0.94. Therefore, the mu is equal to 68.1. Okay, done. Next. Why do I always lose the question? Oh, okay, suddenly they come in. Okay, so x is a normal distribution with mean and sigma square for the variance. Find the value of the mean and the standard deviation if probability for x less than 13 is equal to 0.1587 and probability for x greater than 22 is 0.0228. Okay, so what do we need to do? Right, so wait a minute, bateri habis, kena cas kejap. Bateri apa panggil? Lighting pad habis sekejap. Okay, so now let us continue then. Okay, so x is a normal distribution. We didn't know what is the value for the mean and we didn't know what is the value of the standard deviation or the variance. But right, so what do we have over here is that probability for x greater than 22 is 0.0228. So I will standardize this one because I want to use my table for them. But since this is x, I cannot use my table. I have to standardize them. So we have to change them. So z is equal to x minus mu over sigma. So this is 22 minus mu over sigma equal to 0.0228. So we need to refer to our table. So from the table, probability for z greater than 2 is 0.0228. So this is probability of z greater than 2. So you can easily compare them. 22 minus mu over sigma is equal to 2. Therefore, 22 minus mu is actually equal to 2 times with sigma, which is the first equation. Okay, so now let us use this one. X less than 13 is 0.1587. So let me standardize that one. So z less than 13 minus mu over sigma is 0.1587. So from the table, probability for z less than -1 is 0.1587. So you can actually compare them both. So 13 minus mu over sigma is equal to -1. Therefore 13 minus mu is equal to -1 sigma or negative sigma. So now you can easily solve them. So just solve them simultaneously. So you can actually do the first equation minus with the second equation to solve and find out what is the value of the sigma. Okay, so equation 1 minus with equation 2. So you are going to get the value of the sigma, where the sigma is equal to 3, and then substitute back the value of the sigma into either the first or the second equation. That will give you the value of mu, which is equal to 16. Okay, so now the last example. The length of the house flies follow a normal distribution with mean 2 and variance 0.09. Find the probability that the length of a housefly caught at random is more than 2.28 less than 1.45. Okay, so now if x is the length of the housefly, so that means x is a normal distribution. So this is the mean and this is the variance. So the variance is 0.09. That means this is 0.2 squared. Okay, so what do we want to find is probability more than that means greater than. So probability for x greater than 2.28. So standardize them. So 2.28 minus 2 over 0.3, just in case you forgot. Z is equal to x minus mu over sigma. So use that formula. So z is greater than 0.93, which means that this value is 0.17620. Next, less than 1.45, again standardize them. So what do you need to do? So this is z less than, oh I missed that one. So this is supposed to be probability of z less than 1.45 minus 2 over 0.3. Okay, so when you simplify them, this one is z less than -1.83. Okay, draw the bell-shaped curve. So -1.83 is on the left hand side. Taking the symmetry, you can flip them. So this is on the right hand side. So probability of z less than -1.83 is actually equal to probability of z greater than 1.83. So you can actually find out what is the value for probability of z greater than 1.83, and that is 0.0336, and that is the end. Okay, so thank you very much everyone. Enjoy your day. Bye bye.